Here we go. Hello. Welcome. Again, I'm asking. So, do you do any kind of reading or like anything that you could talk about today? Not yet. Okay. Yeah, I can read your faces. No worries. So today we are going to talk about numerical control machining or CNC machining. So there are like CNC and NC basically mean the same. It's basically computer controlled hand tools. So in the 40s and 50s when the first CNC machines were made, so there were a lot of hand tools, and also when the computers were evolving, so there was a need to do numerical control machining in order to read and make the tapes. So these punch tapes. So these were the first CNC machines made. And then this technology evolved and was applied to other fields, like manufacturing. Yeah, so it's usually the purpose is to do automated things with the manual tools that were previously there, and so that there's no need for a human operator, or you can do like really highly complicated stuff with the numerical control. So you can do really complex shapes, and you can achieve really complex parts. So manufacturing process is also, so there's computer-aided design, and there's computer-aided machining, which is basically CNC machining. So sometimes when you would see software interface, so some kind of a workspace in a software, in CAD software that is called CAM, then you know that it stands for computer-aided manufacturing. In Fusion 360, it was so a year or a few ago, the manufacturing surface, so where you would do toolpaths, it was called the CAM workspace, and now they changed it to manufacturing. So, but yeah, the concept is the same. Today we are going to talk about milling machines at our lab. So we have three of them here. So I'm going to skip those that are at VARA. So since it's so for VARA, there's another digital fabrication studio course, which is going to be this autumn. So this course is for this space. I'm going to focus on the machines here. So we have a Roland SRM20, which is a small milling machine. It's actually now milling a printed circuit board. Roland MDX40, which is a bit bigger, and then Recontech 1312, which is quite big, so you can make furniture with it. So let's start with Roland SRM20. Okay. As a 3-axis, X, Y, Z, you can cut wood, wax, foam, copper for PCBs, and the build surface of it, or the build area, which you can rely on, is 200 by 150. Along X and Y axis, and these are millimeters, and then 70 millimeters along Z axis. Then Roland MDX40, it's a slightly bigger machine. I forgot to add pictures here, but I could just add them in really quickly. Wait a minute, I have them over here. Wait a minute, why they are not here? Yeah, now they are. So this is the SRM20, and yeah, you can zoom in. Yeah, so in the process of milling a PCB board over here. Then here we see this is the MDX40. And then the bigger one is the Exitech 1312, which looks like this. So yeah, today when we are going to set it up, so there's a camera. The second camera is now set up in the CNC room. Yeah, so it's going to be recorded. So I will try to record the setup process, which usually I have to skip because the setup is not all right this time. So it's going to be an interesting challenge to try to show it also in the video. Okay, but let's continue with the slides. So Roland MDX40. So it's a 4-axis machine. So normally you would use it as a 3-axis machine, but then you can install also the 4th rotary axis, which is able to turn the material around, and you can do 3D milling with it. And it cuts wood, wax, foam, copper, and the build area is a bit bigger. So instead of 200, it has 300 along the x-axis and twice that much along y-axis. So on a smaller machine, it's 150. Here it's 300. So 300 by 300 by 100. So that area is 100. So you can cut some quite big objects already. But then Exitech 1312. So 1312 stands for 1,300 and 1,200 millimeters along the x and y axis, and with this you can cut comparably huge objects to the 2 other machines that I just showed. So yeah, 1,300 by 1,200 and 400 millimeters or 40 centimeters in height. So can cut wood, plywood, MDF, plastics, theoretically also aluminium, but the chip extraction solution here, it doesn't support that. And this also only has 3 axes, but you can do quite a lot with 3 axes already. You can make furniture and you can make 3D objects anyway. So let's focus today on Exitech 1312. So you can do furniture, 2D positives, landscape models, so you name it. So the creativity in using this machine is actually the limit. And the tool that we are going to use, so the software tool is Fusion 360. So yesterday we had a brief introduction into it. So today we are going to make something that we can mill with the CNC machine. So we're gonna try a little bit of parametric modeling, so really tiny bit. Then how to assemble our object, how to put it on a material, on a stock digital model. And how to generate toolpath for cutting the parts out. And yeah, the plan is to design the parametric box, then choose the material from our scrap material storage, and then generate toolpaths, and then use the milling machine where we have the camera. And now demo time. So let's open up Fusion 360. So here I still have the project from yesterday. So yesterday we did this little wheel, and for today, let's try to make something else. I have a really simple thing in mind. So for today, for the time that we have today, this would be an overkill, probably. So if you look at this, this is the table that we have in the machine room, in the 3D printing room. So this would be a bit of an overkill. We don't have that much material, so I'm gonna do something smaller, but with the same methodology. So you see these tabs here. So called finger joints, and I'm going to use the same finger joinery in order to make a simple box. So maybe I can find a preview of what I want to make here. No, I think I don't have it here, so I'm just going to stick to this. But yeah, the concept is the same. Also, the same thickness of the material that is joined together. So in parts cut with the machine and parts joined together by using these finger joints. All right, so let's start with new design. I think this time I could activate a thing that is called mouse poser. And let's activate this so you can see where my mouse cursor is and where I am clicking. So let's make it full screen. Can I do that? Like so, yeah. But now then the mouse position thing is not working. That's not good. That's not what I wanted. So yeah, let's leave it like this. And again, so we could start with a sketch, but I think yeah, let's start with a sketch. And let's start. So if you are designing a box, then we should start with the bottom of the box. And that is going to be a square, so I'm selecting this 2-point rectangle tool, and I'm just drawing a random rectangle so to avoid any extra constraints applied to it. Then I'm selecting the line tool, and usually what I do, I add these construction lines, and as you see there's this little triangle appearing, which means that the point that I am going to set is going to be set in the midpoint of the line that it's intersecting. And that means, so if I now hit escape, then I need to see whether I show keystrokes, but I need to show them on the other screen, but then yeah, it doesn't have any option. Okay, whatever. So I hit escape in order to escape the line drawing tool, and when you will, yeah, then you will be able to drag these around. As you see, when I scale the rectangle along x-axis, then the line always stays in the middle. That's because of these midpoint constraint over here. Another thing that I want to do, I want to turn it into a construction line with using this tool here. Yeah, this is a constraint or option rather, and I'm going to add another line to specify the midline from the center line to the midpoint of the right side of the rectangle, of the square rather. Again, I'm hitting escape, selecting the line and converting it to a construction line like so. Yeah, and now I can move it around freely, but if you remember yesterday, then we wanted to have this fully constrained sketch, and this is very important in our case, because we don't know the thickness of the material yet, so we are going to make a parametric model and apply the material thickness afterwards, and the design is going to adjust to the thickness of the material later. And in order to for that to work properly, we need to make sure that all of our sketches, all of our elements in the design are fully constrained. So let's begin. So yeah, the first thing that we need to constrain is that we need to snap this quad to the center of the sketch. So that we can do by using the coincident constraint. So we select that. Then we select the center point of the quad and the center point of the sketch, like so. Now it's snapped. And you see it's still not fully constrained. Yeah, if you remember, it needs to have like this little pin in the sketch icon over here. So that's kind of when the software is going to understand that it's fully constrained. We don't have that there yet. So now when you will drag around the corners, you will see it's always snapping. But yeah, so there are the two last things that we need to constrain. That is the movement along x, so the scaling along x and scaling along y axis. And in order to constrain that, we go to Sketch, add Sketch Dimension, select 1 point, and I usually select a line so that I make sure that it's actually, yeah, that the size that I apply is going along this line. And let's make it to be 10 centimeters, I don't know, 10 centimeters big box. And along the height, let's make it also 100 centimeters. So yeah, here I'm not sure. So there are engineering conventions regarding this, but since my background is painting, I don't know really whether this is the right place for the dimension on the right side of the sketch. I have heard that some people say that the proper side of it it's this one, but yeah, I'm gonna be the alternative one, and I'm gonna put it on the right side anyway. So okay, yeah. So yeah, now if we look at the sketch over here, it has this little pin that means that it's fully constrained, and if we hit escape and we try to move points around, yeah, nothing happens. It's really constrained, so we cannot do anything with a sketch anymore unless we work with the sizes. So we click on stop sketch over here. Now we can start rotating this sketch in 3D space like so. And as you remember, the next thing after sketching, we would extrude it by using the extrusion tool here. But before we do that, so let's set a parameter. Hey guys.
Yeah, so we are leaving.
Please. Yeah, you too. Please keep your voice down. Yeah. So let's add a parameter that will allow us to control the design, to modify the design later, just by using a number. So here we go. Wait, so you can find it under modify and change parameters, like over here. And the place where we can add parameters is this user parameters section over here. And as you see, there's a very inviting plus icon that we can click. So when we click it, then we can give a name to our variable. And the interesting thing is that Fusion is going to force you to figure out a name that doesn't include spaces. So now if I want to enter a name that is material thickness, I won't be able to add a space in between the names. So I need to use more like a programming convention, which would, so in this case, which is going to be a camel case. Yeah, I mean, it depends on who is doing it. You could also use snake case. So this is also a popular way, like a popular convention, how you can name your variables without using spaces. But I'm gonna stick to camel case, like so. So units are important. So we are still talking in millimeters, and then for expression. So I'm gonna go, let's say, for 16 millimeters plywood, and for a comment I will enter this can change. Okay, now we have this parameter here in the table, and we can also remove it if we don't want it anymore. But yeah, if we made a mistake, or if we made a mistake, we can also double click on it, and yeah, on the fields, and you can change them. So, and that's the idea, so that you can change this later. And you hit OK. And now we can go to create extrude. Click on the extrude tool. Ta-da! Extrude. And now in this number field, instead of a number, we can start typing, and it's going to give us the parameter over here. And we have to hit enter twice, and yeah. Now it's 16 millimeters thick. And just to demonstrate to you how this works, so after saving, finalizing the design and saving it, you could go opening it up again. You could go to the parameters section, and you could change this to, let's say, 30 millimeters, like a really, really thick plywood there, MDF. And you see it changed. So in order to make sure, you can use this inspect tool in order to select an edge, and it's gonna give you the length of the edge, which is 30 millimeters. I'm gonna go back to something thinner though, so to 16 millimeters again. And again, if I use the inspect tool and click on the edge, then it's gonna give me the parameter, so the 16 millimeter thickness. All right, so at this point, I think it's a good idea to save it. I'm gonna call it parametric box and put it in the lab objects folder. Next thing is we have to build walls around it. So in order to build a wall, I'm gonna design I'm gonna sketch out a profile on the top plane of the box. So I'm gonna select the sketch tool, select the top part of the plane, enter the sketch workspace, and here I'll just draw a circle, not a circle, but a square. These are rather two different geometric objects or geometric shapes. So yeah, and then I'm gonna try to snap it to this corner over here. It's the first corner over here, so it's gonna add a constraint for that automatically. And then I'm also trying to snap it to the line, to the bottom line over here. And that's a cool thing about Fusion, that you can reference other sketches and other objects in the design. So you can snap your sketch to objects, to existing objects in your design. So this is also, it's probably based on the history that you have down here. So if you change something in the history, then like the objects, they keep their names, and yeah, if you change just a few parameters, then the objects still keep their names, and the software can figure out which points are actually aligned to which objects that were created earlier. Now, yeah, you'll see you can drag around only this line. So this here is constraint. This here is constraint. So if you click on the individual ones, you can see that this is perpendicular to something. Here, that this is coincident to the line, and so on. And yeah, so we also need to achieve a state when this is fully constrained, when it has this little pin in the top left corner of the icon in the browser. So we are going to go to sketch dimension, and add a dimension in between this line and the corner over here. And here, so since it's going to be a wall of the same material that we are going to choose, so we can also use the material thickness here. Hit enter, and you see if you are using parameters in sketches, then in front of them this FX label appears. Yeah, so 16 millimeters. And now if you look at the sketch icon, yes, it's fully constrained. We are good to go. So let's hit stop sketch. And now we can extrude. So let's extrude, select this face, and yeah, let's look at the extrude panel. This is important at this point. So everything is fine. We start from a profile plane. We do only one side extrusion, and we define a specific distance for it. And no taper angle, the distance is still 0, but we can set it to, let's say, 5 or 50 or 40. And instead of, so the operation in this case is important. We don't want to join it yet with the existing part, but we are going to create a new body, like so. Okay. And yeah, as you can see, it already looks a bit bulky, so maybe making a box that is this small, it's you know, it's a bit too small, and it's not gonna look good. So how about we go back and change the size of the sketch, and actually how about we make the width and height and the depth of the box parametric. So let's add a little bit of flexibility to it by changing parameters, and let's add a few more parameters. So it's going to be box width, and for starters, let's enter 150 millimeters. Okay, then I'm going to add box or I think that I'm always struggling with these. So whether the z-axis is depth or height, right? So because this time I'm going to use like box size along x-axis, like so, and then I'm going to use box size along y-axis, which is going to be 150 again. Okay, and box size z, which is going to be the height. So we're going to use 50 is going to be not enough, so I'll go with 75. All right. and I will hit OK. And now I can go back to the sketch, the first sketch that I made, double click on it, so here in the timeline, and I can change these values to box size. Why can't I see the box size X? Let's see. Both. Yeah, that's the reason. All right, thank you. Box size X, enter. Yeah, you see it stretches, then box size Y, again like this, and stop sketch, and you see it automatically adjusted everything, even the other sketch over here. If you double click here, see everything snaps still. Beautiful. And then for the extrude, we can just modify this distance parameter to box size Z, and if we want it to be, if we want the box really fit into this kind of boundary box that we define by the parameters, then from this box size Z, obviously we need to remove the thickness of the material. So because we don't, yeah, so we can do mathematical operations here. What a surprise! So material thickness. You see, yeah. Now it's, if you are going to measure, if you're going to use the inspect tool, so with this edge and you select this edge, so you see, so there should be a full distance or something. Or let's close this and let's measure the distance between this edge and this edge. So yeah, it's 75 millimeters. So which equals the, if we check the parameters, which equals the height of the box over here, 75 millimeters, box size. That's, yeah. So that's that. And now, instead of drawing another sketch on this ground plane and to create the opposite wall, we can use a really nice function which is called mirror. And in order to use the mirror function, we need to choose the pattern type, which is going to be bodies. And for the body, we are going to select this wall that we just created, and then we need to select the mirror plane. And you see the construction planes, the original construction planes of the design appeared. So there are planes and axes, and there was also the initial reason why I created the sketch in the middle. So this first rectangle in the center of the coordinate system, because now we know that this construction plane over here, it's gonna be exactly in the center of the bottom of the box. And when we select that, we see that in the representation, the object that the wall that we just created is really nicely symmetrically mirrored along this axis in between Z and Y. So around this plane in between Z and Y axis. Yes, there are so many terms. All right, so now we have two walls. So how about having the other walls over here? So for that, we still are going to create a sketch because we need to create at least one wall over here. So, and again, I'm going to select the top surface of the bottom part of the box, like so. And again, I'm going to select the 2-point rectangle, and I'm going to try to snap it to existing elements, like so. And I'm going to add a dimension between here and here, and it's again going to be the material thickness. And yeah, the sketch is fully constrained. That's really nice. Let's stop sketch, rotate it, and again, let's extrude. Select the face that we want to extrude, and again, let's check that the operation is new body. So that's important. And let's extrude up, and insert the same variable or parameter that we used before, and we also need to use a mathematical operation, material thickness, and let's hit OK here. And now, as you see, it joined, and this is what we didn't want to do. We want this part to have separately. And luckily, we can just double click on the feature over here in the timeline, and we can just change this operation to new body. Okay. Now we have a nicely looking third wall. And let's use the mirror operation again. So create, mirror. We need to select bodies as the pattern type. We select this shorter wall and the mirror plane that is in between X and Z axis. So, and here we have it. Okay, almost ready. So now, yeah, if we mill these, then how are we going to connect them together? Not easy. So with glue, yes, but we want to be able to connect those without the help of glue. And in order to do so, we are going to design so-called finger joints. And before I do that, I'm going to open this bodies container over here, or like folder, and I'm going to give names. So it's going to be bottom, no, not bottom, but bottom. So if I look at I want to look at it in so this is front. So I'm going to give the names of the walls according to the names that I have here on the planes in the representation. So in the navigation guide, so to say. So I'm going to. This is bottom. Then this is going to be front. And this is the left one. This is going to be the back. No, this is the back. And this is going to be the right. All right, we have these. And now, so yeah, if we're looking at onto design from front right, then we can hide the left back, like so. In order to start to design a finger joints here. And in order to do so, we are again going to create a sketch. So here. And we are first going to start by drawing a midline between those two. And I'm going to turn this into a construction line, and I'm going to add 2 additional lines, one here and another somewhere here. And as you see, I can move them around freely now, so they are not really snapped to the midline. But what I want to do, I want them to symmetrically move, to have the same distance from the center line over here, so which is not moving, which is really nicely snapped to the middle of this profile. In order to do that, I need to use the Symmetric Constraint, this one here. Can you see it? Yes. Okay. And I need to select one element, which is already selected. Then the second one. So as you see, Fusion guides me really nicely with these labels. Second one, and then a symmetry line, so which is going to be the center line over here. And now they are symmetric. So if I hit escape, I try to move these lines, then they are going to move in a symmetric way. Now I need to decide on the length or the height of this, and for that I'm going to use the dimension tool. So sketch dimension, point, line, drag, and I think I'm just going to use half of the height of this one. So let's use a mathematical operation again. So box size Z minus material thickness. So this is going to give us the height of the wall, and I'm going to put this equation into parentheses like these. Parentheses or brackets, what is the correct term? And then I'm going to divide this by 2. Yeah, here we go. This is gonna be my finger joints, first one, and let's take a look at this sketch icon here. Yeah, it has the pins, it's fully constrained, it's all nice, good to go. And now we need to extrude it. I just hit E to extrude. And yeah, we need to extrude it by the amount of material thickness, since this space here is equal to that. And what we need also to make sure of is that we don't join it yet. So let's create it as a new body. Okay. And now, so in order to, so we need to get it on the other side, and for this we can use again the mirroring function. Yeah, let's just do that without hiding anything. So let's go to create mirror. We need to select bodies again. We select the finger joint as the body, and then the mirror plane over here, like in the center of the design. And you see it's showing a preview over here already, like this. And now, once we have both of the sides, we can actually merge them together with the object. And this is a nice opportunity to introduce you with the combine tool. I think we covered it yesterday, but it's a nice opportunity to look at it again. Combine, target body is going to be the wall itself, and then tool bodies are going to be these. And remember that we last used the cut operation, but we actually want to use the join operation. And we don't want to keep tools, and we don't want to make a new component, so we just hit OK. Now it's like this. And now it's intersecting with this line, but it's not really cutting through. It seems like it's cutting through, but then if we hide this, so the front part, you see that there is no pocket there, so we actually need to create it. And for that, we can use the combine tool again. So we go to modify, combine, target body is going to be this wall that we want to cut in the first place. Then tool body is going to be this one. And instead of joining, we want to cut. It's going to be like this. And this time we want to keep the tool because we don't want the other wall to disappear. We just want to use it as a tool and then keep. And now we have it here. And now I think we'll have a problem here because for the back wall there are no tabs anymore. And yeah, in order to make it right, I think we will need to go a few steps back. So let's go here, here, before we actually merge these. And what do we want to do? We want to also have these on the opposite side. For that, I will. So yeah, just notice I went a few steps back, and actually, after going a few steps back, I can delete all the features after the history marker, so which is this line with a triangle, you know, kind of a head of a player, playing head. And in order to involve a bit more clarity, I will hide this right wall over here. And let's use the create mirror tool. And pattern type is going to be bodies. For the objects, I'm going to select these tabs over here. For a mirror plane, I'm going to select the plane over here. And you see it nicely aligns with the wall on the opposite side. Okay. And at this point, we can combine them together. So we go to modify, combine. So let's select this and that. for the operation, let's select join. We don't want to keep tools. Okay, and let's do the same for the other wall. Modify, combine, tool bodies, operation join. All right, and now when we unhide the left and right, then we can use yeah, these walls with tabs in order to cut pockets. Let's start with the right. For the tools, I will select both of the sides, so the front and back, and then instead of a join operation, I'm going to use cut operation, and I'm going to keep tools. Hit OK, and I will repeat that with the opposite wall, with the left wall over here. So again, tool bodies are these, and I'm going to use the cut operation and keep tools again. Okay. And we can also change the visual display to wireframe, for example, to see how it looks like. I don't know, wireframe with hidden edges. It doesn't make much difference at this point. So we'll go back to that. So yeah, if I check the right and left walls, I see that I have these with tabs, and if I hide the front and back, I see that the left and right are with pockets. And now, how about so how we are going to connect them to the bottom side? Good question. So I'm gonna. So we'll need a tab that is kind of a finger joint that is somewhere in the middle, 1 or 2, that is connecting to the bottom side. I think I'm gonna go with 1. And for that to become reality, I'm going to hide the bottom part of the box first, and I'm going to start to create a sketch on one of the surfaces of on the back surface, on the bottom surface of the left wall, like so. And I'm going to use the same strategy as before. I'm going to start with a midline here. I'm going to turn it into a construction line, check whether it doesn't move. It doesn't. And then add 2 extra lines, one over here, the other here. And yeah, make sure that they are symmetrical by using the Symmetry Constraint over here. So I need to select the second sketch element already because the first one was selected already. Why it doesn't want to select? Or this is selected and then wait. Yeah, I need to select the line instead of the point, and then click on symmetry, another line, and then the symmetry line, which is going to be this. Now let's check whether they move together. They do. And in this case, I think I'm going to choose not half, but 1/3 of the length of this one, and it's going to be box size along y-axis. So sketch dimension, this point, that line. No, at this point, that line. No, wait a minute. One more time. Escape. Sketch dimension, this point, bottom line, like this. And again, I'm on a mathematical operation, so let's size y divided by 3. Ta-da, here we go. So since it was 15 and now this is 50, so the 15 centimeters or 150 millimeters, then this is 50 now, which seems to be correct. Now we can stop sketch. And we can extrude this by using the extrude tool. Let's select the face over here, extrude downwards and use material thickness again for the extrusion. And again, it joined this, but this is what we don't want really. So we are going to create a new body. Okay. Theoretically, we could now use a pattern to rotate these around to copy them. So let's do that, and then I will show you what is wrong with that in this context. The pattern, circular pattern, bodies. So this is going to be the body that we are going to use for the pattern. Yeah, the object, and then for the axis, we are going to select the z-axis exactly in the middle of the design. And for the copies, I'm going to select 4, and it's kind of seemingly all right, so it fits really nicely. But now, since we defined different parameters for the x and y axis, let's see what happens when we go to modify, change parameters, and we change the box size y to 200 millimeters. Okay. Oh no, what happened? So pattern, so the circular pattern, actually it's not the right tool for this case. So if you want to make a parametric box like this. So let's go a step back.
Is it because it's constrained to the CNC?
Yeah, it's just rotating the object around the one axis, and it's always using the same distance, but then it's not taking into account, it's not snapping to the y distance here. So we need to use a different strategy. So we go a step back, we delete the features there, and we just will need to create another sketch over here. But before we do that, we can just mirror this. So let's go. So you see that through the course of designing this, you can see that you basically, if you need to master a few tools, and you need to repeat them in order to achieve your goals in life. So you create a mirror, and you would select the object, and you will select the mirror plane again, which is really nice that we started the sketch in the center of this area of the design. So now when we mirror, it's exactly in the opposite side, and exactly hitting the wall on the other side. So nice. And let's create another sketch over here. Create sketch, select the face, and again, let's start with creating a midline over here, converting into a construction line. Did it work? I think so. Then one random line, but perpendicular to the walls over here. It somehow doesn't work that easily. What is happening now? Something going wrong. Completely wrong. I'll do it more from scratch. So I'm going to make this random line over here. So first, I'm going to make it perpendicular to one of the lines over here. And I'm going to convert it into a construction line right away. And then I'm going to make one of these points to match the midpoint of this line. So now it seems to be constrained. Yeah, there's also this little pin. Yeah, and let's add the 2 other lines in a similar fashion. So again, let's make it perpendicular. That's fine for now. Another line. Again, let's make it perpendicular. And now we need to get them symmetrical, so as they do not move together. So we use the symmetry tool. Like so. And yeah, so they move together. And let's add a dimension in between those. Again, point and line, like so. And again, let's use 1/3 of the length of this specific element. So we'll need to do a bit more math than with the other wool. I'm just wondering, was the wool with the pockets, or was it the other one? Actually, you can do it like so. Ah, it was the other one. And you can go back to the flat display like so. And I'm gonna start with parentheses right away. So we need to get the box size along x-axis in this case. So box size x, and we need to subtract the thickness of the material, which is actually affecting the size of the box on both sides. So we need to multiply it by 2, and multiplication is going to happen before subtraction, so we don't need to use any parentheses. Of course, it's always safer to do so, but in this case, no. And I'm going to divide all that with 3. Yeah, now it's exactly 1/3 of this smaller part over here. Let's stop the sketch, and let's use Extrude to extrude these. And we don't need to join, we need to create a new body. Okay. Let's just make sure that it actually is the size that we want. Yeah, 15 millimeters, really? No, 16. Did I enter the material thickness here? No, just 15 millimeters. So I need to add material thickness in order to be completely precise, like so. Yeah. And now we are going to use the mirror tool again in order to copy this over to the other side. Okay. Now we have it. And now we can proceed with joining these together. So let's go modify, combine. Let's select this body first, and this is tool body. And instead of cutting, we want to join this time, and we don't want to cut to keep tools. So we uncheck this and hit OK. And let's do it 4 times with other wools. So really quickly. No, this is interesting. So the tool is designed in order for you to be able to select only one target body. So you cannot, if you go back and you select something else, it replaces the selection, and right away jumps to the tool body. And okay. Yes. So, and now if we unhide the bottom, and hide the other bodies, we will see that there are no pockets for the other tools. So, but now it's going to be easy, because if we use the modify combine tool and we select the bottom part of the box as the target body, and then the sides as the tool bodies. Something going on with selections. So yeah, if you don't want to, if the design becomes very dense and it's becoming very hard to select, and first of all, you can also filter. You can use the selection filters in order to make sure that, in order to filter out the elements that you don't want to select, or you can actually use the browser on the side in order to select the object separately. And instead of joining, we want to cut, and we want to keep tools. Okay. And at this point, I'm going to save. I'm going to say for the version description that design ready. Like so. And yeah, at this point we can go to modify, change parameters, change this to 25 centimeters and this to 30, and the height to, let's say, 150, and hit OK. Wait, something unexpected happened. Yeah, of course it's quite small, so not 30 but 300, and then this is going to be 50. Okay, and yeah, so you see everything grows really nicely. So this is our parametric box, and I'm wondering also, yeah, we could change the calculation for the tab here on the side, for example. We could also make it 1/3. So how about we do that? Yeah, why not? Because it's all there. So I'm wondering. So this is for the bottom, and this is for the side. So let's go in here. Let's click on the function over here. Instead of 2, let's do 3. Stop sketch, and yeah, and it happens. You see, it's all automatically updating. That's that. I got this material over here, so like a scrap material, like a piece of plywood, and I measured it also, so it's 1,104 millimeters by 220, and 16.7 millimeters thick, so approximately the same that we put into the design. So if you want to check the material. And yes. So let's take that into account and try to adjust the design so it actually matches the material that we are going to use. So first of all, we need to change the parameters, so the thickness of it. So it's 16, but we just need to add this 0.7 over here. Hit OK. So nothing much changed. And since it's 220, I think that could be the maximum height of the box. So let's see. So these are obviously too big. Yeah. So obviously not the most comfortable object to pass around, but since we are not so big in numbers, then it's okay. So let's stick to the 15 centimeter box, like 15 by 15, and let's make it 10 centimeters high, like so. Yeah, it kind of looks good. So this could be a perfect box for housing the some flash drives that are always all over the place. So we have basically this little box over here that could be a good example. Then there's that. So this is the box where we keep the milling bits in, and it's basically made by using the same method. Maybe from a little bit thinner plywood. Not plywood, that's actually MDF. And then yeah, the labels are cut with a vinyl cutter. Yeah, and so there you see it's a bit different approach. So the tabs there are 2 on the bottom, and then on the side there's only 1. So this is going to be a slightly different design, but okay. I suppose also that you could do more complicated parametric tricks. For example, if one side of it is longer, then you could automatically determine how many shapes you want to have on the bottom profile. So whether you want to have only 1 tab or you should have more. That's one thing to explore. Okay, so in order to make this as humanistic, humanistic as possible, then we are going to create a specific object that is going to represent our material. So I'm going to hide these, and I'm going to create a new sketch which is going to represent our material. And I'm going to start with a rectangle like so. And as before, I'm going to start with a few midlines over here, and I'm going to convert these into construction lines like so, and use the coincident constraint in order to snap to the middle of the stage like so. And I'm going to enter values, but in this case I think I'm going to stop here, and I'm going to add a few parameters. So material size along x-axis is going to be 220, and material size along y-axis is going to be, how much was it? 1104. Like so. Okay, and here we enter material size x, and here let's add a dimension, material size y, like so. Let's stop sketch, and let's use the extrude tool in order to extrude by the amount of material thickness, like so. Yeah, so now when we unhide everything else, we see that it sits on top of the surface over here. Yeah, and the next step is to create all these into components. So there are many ways how to create the tool paths, but so the easiest to understand, I think, is this, that you lay out all of the parts on the material, and then you create the tool paths. But then you can create tool paths also individually, creating tool paths for every other part without disassembling them. But then, yeah, let's do the assembly. So, but first we need to create these as components, and when you select all of those here in the browser panel, you can do so by selecting the first, then hitting Shift, like holding down Shift key on your keyboard, and clicking the last element in the list. So you can select all of those. You right-click, and you should select the Create Components from Bodies option. And now you see something changed. So the bodies drop-down disappeared, so there are only the sketches visible, but each of these were transformed into components. And the difference between bodies and components is that, so here, if you look at our project, so it has this origin, so this global origin object over here, so which represents the axes and the planes. And we were designing these objects against this origin. But once we are creating components from bodies which are designed against this global object, global origin, then in the component itself, the origin is actually copied. So the bodies inside and everything inside the component, they have their own origin, and the bodies are designed against this origin. So like so. So each of those, now you see they have their own origin. And then the components themselves, they are aligned, or they are laid out relative to the global origin over here. So yeah, that's the main difference. And of course, however, if you roll back in the history line over here, and you change anything, then it's gonna update anyway. So let's say, yeah, let's see how this works. So now, in order to lay them out on this surface, we need to use this assemble menu. But before we use that, we need to somehow hold down the material. So I'm just gonna move it somewhere. It's not really easy to move it around, so it's somehow alphabetically ordering it. So we need to use a function that's called ground. So ground means that we are going to somehow stop it from moving around, so like this. And then we need to use the assemble menu, and we are going to create joints between surfaces. So surfaces of the parts of the box that we are making and surfaces of the actual material object. And let's hit cancel because I don't want anything to be selected at this point. So assemble joint, and yeah, let's start with this one. So with the outer surface of this wall of the box, and let's snap it to the surface of the top surface of the thing. And yeah, you see there you have to select two components, which in these cases were faces. And for the motion type or the alignment type, we need to select planar. So we need a planar alignment. Something weird is going on. So where's this object? Why it's not? I still need to select the other one. So let's just align it here. See, it's going to slide it around the surface like this. But then, as we are going to cut it out from the material, we need it to be inside the material. So for that, we need to use this flip option over here. So it's gonna fit into it, and okay. Now we can also drag it around and position it wherever we want on the surface. And let's do it with the rest of those joints. Let's capture position. Yes, that's okay. And again, you can snap it. It's very important that it's snapping with a top surface, that it's not like somehow 45 degrees on the edge, but it's, you see that it's actually really aligned, like in parallel with the surface of it, like so. I would normally do it in the center, but since there are other objects in the center, it's kind of difficult. Yeah, and I can hit OK, and I can again move it around like so. And let's do it with the rest quickly. So joints, yes, capture position. It's very nice. Let's put this somewhere in the corner. I forgot to flip it. So yeah, let's flip this one. And however, I can go back to this one, open the menu. Here, or which one was it? Why it's not opening the menu? Okay, wait a minute. Something went wrong. Finish capture in position. Yes, like this here. And instead of capture on position, I need to, yeah, open this menu here, and I need to flip it. All right. Yeah, now it's flipped. It's all right. Let's continue with this one, like so. Like this. Let's flip it. Okay. Move it somewhere. Yeah, and this is somehow flickering. It's kind of tricky, but it's still possible. So yeah, I'm going to select this and position it against this one here. And flip it. Okay. Yeah, and now if I click on the material, I can make it also unselectable by using this menu item. So it's not going to stand in our way when we are going to try to move these around now. So you can just select them really easily and move it around. And yeah, let's check. So if we are looking at it from the front, then we want to kind of save the material as much as possible also. So we are going to lay it out in a more like economic fashion. So not the most economic one, but still. Like so. Yeah, so now we have it. So it's laid out. So this is how it's going to look on the CNC machine. And now all we have to do is to create paths for the tools in order to cut them out. So in here, like for this example box, so with the example box, I also got tools, and we can choose what tools we want to use. Since it's a smaller box, we would like to use a smaller tool in order to be able to cut so these corners here, which is another issue. So since the milling bits are round, we are not going to be able to achieve sharp corners like these. So we need to do something in order to kind of adapt these corners to adapt to the tools that we are going to using, and this is when it comes down to a term that is used in cutting this snap fit furniture, which is dog bones. That's more like the slangish version of it, but it's T-bones. Yes, T-bones. So yeah, so before we do the T-bones, we need to decide also what tool we are going to use, and we have like 8mm tools, 6mm tools, and also a 4mm one. Also smaller. I think I have 3mm, but I think like 4 or 6 would be the way to go. I need to measure this one. This looks quite good. This could be good. Just need to get a caliper quickly. Yeah, so you see, if you see, it's going to approximately 4. Now it's actually exactly 4. It's just that my caliper skills are not the best, and you see, you measure the diameter, so you always need to know the diameter of the tool. And this one also has 2 flutes, so meaning that it has 2 cutters. So that is also one important property to know. The other ones are like the amount of so how high is the part which is going to be able to be cut. To cut, yes, and the overall size, but we're gonna get to that. So now, let's use this 4mm tool. I think it's gonna give us enough detail. And here in Fusion, I have like a dog bone plugin installed. So I can show you later how. So you can get it on the internet. There's a Git repository. So the dog bone plugin for Fusion 360 GitHub. Yeah. So this is the website. So if you want to install Dogbone on your Fusion 360 installation, then here on GitHub you can get it. Version 2.0. Yeah. So and what it does, it creates these dog bones or T-bones for you to be able to assemble parts together in a snap fit fashion. So exactly what we are going to do now. So with all the instructions how to use it and so on. But our use case is very, very simple. So let's go back to Fusion. So all we have to do is to select the dog bone, and then in the dog bone menu we need to specify the tool diameter, which is going to be 4 millimeters. An offset 0.1 is fine. Static dog bones, we don't want parametric at this point. Normal, yes, these are default settings, are fine, and we don't need to debug it or whatever. And then for the face, we can select also multiple faces, like so. And it's going to identify these edges, and it's going to go all the way down and create dog bones for those. Yeah, like so. See, it created these little circular things. Yeah, and at this point we are ready to create the toolpaths. In order to do so, you go to Manufacture workspace of Fusion 360. Now you see that the top part of the tool menu, so the tool menu up on the top part of the screen changed, and you can see that there are all kinds of more like manufacturing and milling related operations, and we are mostly, yeah, we are going to use only these few in the beginning. And the first thing that we need to do in order to create toolpaths, we need to create a setup of the machine. So we go to Setup, New Setup. Again, like this interesting menu over here. We can leave the machine part empty because like our machine is anyway not on the list. Then we just need to make sure that it's milling. Then orientation. For the orientation, we can basically leave it as the model orientation, but we need to select the stock point, which could be in this corner. But before we do that, we need to specify which is how we are going to treat the stock. So what is going to be the stock? And in our case, it's not going to be a relative size box, but it's going to be solid. So the material that we actually made from sketch. And solid means that we need to select a body. So here we have our project, yeah, under models, and here we have the components, and here we have the material, and here we have the bodies of the material. We need to select this. And it's going to measure this object and assign the stock material properties. So basically it's going to create another virtual representation of this piece of wood. And then we can go back to Setup, and now we can select the box point, which is going to be this corner over here. So it's going to be the top surface of the material. So it's going to be important for the milling machine in order to understand where it has to where's the 0 point of the z-axis. So it needs to know what is going to be the surface of the material, so it knows how much deeper it needs to go in order to cut through the material. So stock box point and the model that we actually want to cut. So for that we can select all the bodies. So back, right, left, front, bottom. Yeah, these are 5 bodies. So this is the model that we want to cut. And if we would use specific fixtures, so some clamps in order to hold down to the milling surface. So we are going to touch this in a minute when we are going to the milling machine. Then we could also enable fixtures and select models. So we could actually add real representations of real fixtures, and then the toolpath generator would calculate its way around it. So once we have the setup, you could actually hide the material because the virtual material representation is visible anyway. So it's kind of a semi-transparent volume in the manufacturing workspace. And from here, we can start with creating a cutting contour, and we are going for the 2D contour, just like that. So, and first things first, we need to select a tool, and this is also a nice part. So I like Fusion because here you can also see how so you can understand more about tools. So I didn't have specific slides that you would that would explain you how the tools work, or like about feed rates or anything, because I think that through Fusion 360 and through similar CAD/CAM tools, you could actually understand more about the process than through slides. And here you see in my local library, I don't have the 0.4 millimeter tool. So thus we need to create one. So I'm going to create new mill tool by using this icon, and a menu like this appears. And I could specify the description, so 4 millimeter, 2 flutes, as we remember, and 2 millimeter, 2 flutes, flat end. So this is all we need to know about it. Then we need to specify the cutter. So in our case, it's going to be a flat end mill. So you see these are like all kinds of cutters that are being used in the CNC world. You know, you can do all kinds of interesting slots, for example. So I would like to get some of these in order to try them out with the machines that we have here. But in this case, it's going to be just flat end mill. And number of flutes is essential. So it's going to be 2. Material, it's probably high-speed steel, yes. Unit millimeters, yes. Diameter, 4. Also, the shaft diameter is going to be 4. And yeah, the shoulder length, let's measure that, or like the flute length. So it's important that the flute is long enough in order to cut through the material. So, oops. Actually, sorry, I closed it down, but I shouldn't. So yeah, the cutter still. So flute length, it's actually 30 millimeters. Then the shoulder should be a bit more. So probably like it's 32. Body is gonna be 35, and the overall length, it's 5 centimeters or 50 millimeters. Like so. And here you can also see a live representation of the tool. So, and then yeah, you could theoretically change the holder as well, the holder design, if you would like to be very precise with your machine. But we are not doing this here, so it's a bit too much work at this point as well. But for feeds and speeds, so this is a very important part, where you basically start from trying to figure out or kind of finding the feed per tooth setting, which is different for. So you get that by knowing what is the diameter of your tool and what material you want to cut. So when it rotates, so each of the flutes, so each of the cutters here, it's chipping off a little bit of material, and according to the spindle speed, so how fast it turns, the way it moves, so the speed it moves forward can be different. So the slower it turns, it means the slower it can also move forward, because with each turn it's chipping just that amount of material, not more. If it turns faster, that means that it removes the material faster, and that it can also move faster around. So here at Fab Lab we have a table with recommendations, but I'm just gonna take that and try to find a table on the internet that has the same values. So, but here basically we have, you see, a table. There's a diameter of the tool, and then the recommended values for the materials. So that's, yeah. So for a tool like that, probably like 0.1 millimeter could be okay. But let's just quickly try to do a Google search about those, which uploads. Yeah, these are are usually in inches. Yeah, I think this is it. Yeah, so this is the page. I think this table is also taken. So the table that was printed out here, it's from here. Yeah, it matches perfectly. So yeah, we have a 4mm tool, which is somewhere in between 3 and 6. So let's see. Let's take a look at the 3 one. So it's a safe way to go. Hardwoods, softwood, plywood. So we have this looks like a relatively soft plywood. So should choose something in between 0.1 and 0.15. So since we have a thicker tool, then we could use this. We can go with 0.15. So yeah, let's just go back to Fusion and do that, 0.15. And the next thing that we need to know or specify is the spindle speed. Our machine is, the Exitech 1312 is able to support speeds up to 1800. So, no, 18,000, sorry. So we are going to go not with the maximum, but with something like this, like 16,000 RPM, which is going to give us 4,800 millimeters per minute feed rate. And this is no magic. This is a really simple formula, actually. So I'm just going to open this preview window over here. So all you need to know is the number of flutes, which is 2. Then you need to multiply that with the chip load, which is 0.15. And you have to multiply it with the spindle speed, which is 16,000. And you get the feed rate value. That's that. So so this is one of the most important aspects of CNC milling. So just keep in mind this formula, and you're going to be fine in most cases. There are many details, but this is one of the most important ones. And then for lead-in, so we don't have anything like really detailed, and we don't need necessarily a really good and smooth finish. So we can go with half of the cutting feed rate, which could be like 4,800 divided by 2, which is 2,600. No, 2,900. Yes. No, or no. Wait, I'm bad at maths because of computers. Computer age is hitting hard. 2,400. And ramp, here we could go with 1,000. And plunge, so plunge means the movement, how fast it goes downward, so along the, so it's plunge, yeah, along that axis. So let's set that to 1,000 as well. We can go more, so we can, for revolution it could be 0.1, so 1,600 is fine. Yeah, so general name of the description of the tool is important, then cutter is important, and feeds and speeds are important. Now we can hit OK. And here we go. You have the entry of the tool. You can select that and hit OK. Now, once we have the tool, we see that something happened with the menu, but yeah, there are ways how to get it back. That sometimes happens. Yeah, let's close this models area in order it not to distract us. And so once we have this, the setup, then what happened? I think there was the 2D contour, and now we can select tool. But what? Wait a minute. Yeah, actually we were specifying this 2D contour. Sorry, but we can, yeah, we can open it up again. What happened? I'm sorry, like, we're in the middle of the process of actually specifying the 2D contour. So let's start again. So we have it set up, and we need to create a contour path. Let's do that. For the tool, so since we just created a new tool, yeah, we can select it again. It's 0.4, no, like 4 millimeter diameter tool. And once we have that selected, we can go to the geometry tab over here, and we can select the geometries. And we need to select the lines that are the deepest lines in the material that we need to cut, that we need to reach. And in this case, these are these here. And make sure, so there's this little arrow. That the little arrow is outside the parts that you actually want to cut. So unless you want to make negative, so you would like this to be cut out of a material, and you would like it to match the exact size of your design, then you would cut with a cutting tool inside, and yeah, it would leave the negative intact. So you wouldn't use the actual material, the actual part. But we need this arrow to be outside, so the actual part that we cut out is being used, is precise and usable. Let's select the other ones, like so. Yeah, and by default, it's putting this arrow on the outside, except, no, here as well. Another thing here you can see in the geometry tab is that we can use tabs, and in milling it's important because this is going to hold your parts down after cutting. So what you don't want to happen is that the parts that they fly away after they are being cut out. So this is why we need tabs. So we hit on tabs, and there's a possibility to place them automatically. So you just need to decide how thick they are. I'm gonna go with 6 millimeters and 2 millimeters in height, and the positioning by distance is fine. So it's what it's gonna do. It's gonna add these little rectangular cubicles or volumetric objects, if you wish, so that when a part is going to be cut out, it's going to be held down by these little pieces of wood, leftovers of the material. But if you don't like the layout of those, we can also place them manually. So if I select points where they could be placed, so since we don't have too many parts, then I think it's okay. You need a bit of patience to place them manually. It's not impossible.
Should I just start the drilling, replace the tool and start it?
Yeah, so I think you can do that.
Don't need to do anything but replace the tool, right?
Yeah, what I was doing is that after the calibration, I would go 3 millimeters up and calibrate it a bit upwards, so it doesn't cut the full way through. So you can flip it around, and you can also do the drilling from the other side. And I generated two kinds of tool paths there. So for the drilling from the front side and drilling from the back side. So you can do that.
But I need to raise it up one after calibrating.
Yeah. So, but to give me 5 minutes, I'm gonna finish this tool path part, and then make a 5-minute break, and I'm gonna show you. So yeah, let's finish placing the tabs over here and over here. Maybe here. Here. Some have more, some have not that many. But yeah, generally seems enough. Okay. Then that's it for the geometry part. Heights, we're gonna not not touch them. Then passes. For the passes, this is all right. It's okay not to touch that. But what is important? It's important to select the multiple depths option, and yeah, we can specify the roughing step down. So step down means how deep it is going to go per one iteration. So the tool itself, so it's kind of a fragile thing, and you cannot cut the full thickness of the material at once. So it needs to go in many passes. And each pass has a certain depth, and that depth shouldn't be deeper than the diameter of the tool. In this case, it's 4 millimeters. And, just for safety, I'm going to go with 3 millimeters. And then for finishing step down, we don't need like any special finishing, but well, anyway, just for clarity, I'm just going to give it a 2 millimeter step down. Yeah, like so. Yeah, we'll close this. And then stock to leave is a nice thing to have, because, for example, if the parts do not fit together, that means that maybe you have been using the radials stock to leave, or like, you know, if you don't leave any space, if the radial, it means along X and Y axis. So how much more material or how much less material you would like to cut off the parts that you're actually cutting. If you leave 0, then it's just gonna leave the sizes, so the parts exactly the size as it is in the design. But with bigger CNC machines, there's they are spinning really fast, and thus they are not necessarily always 100% precise. So there's this thing that is called run out, which means that the tool is spinning not exactly around its center axis, but it's running a little bit out, and thus it's creating like this extra cutoff. And you can compensate that by specifying this stock to leave. But at this point, I'm gonna leave it to 0. But what I'm going to do, I'm going to use a negative axial. So the representation image is kind of wrong. It should just show z-axis and some extra things. But I'm gonna specify. So yeah, it's along a z-axis, the same but along the z-axis, and I'm going to specify a negative one, minus 0.25, let's say, in order for the tool to cut through completely. Yeah, so, and that's it. Now I can hit OK. It's gonna give me 2 paths. You can see this is the blue lines. These are actually the lines the tip of the tool is going to travel through. And if you look from the right side, so from the side of it, in orthogonal view, then you will see that one of these, the last blue line, it's a bit below the actual model. So this is the actual stock to leave along z-axis. So this is the yeah, radial or axial? Axial, yeah, axial stock to leave. So for example, if I will go back here in the passes menu and tinker with this, and I'll say that it's gonna be 0.1 and hit OK. You see it shrinks. I'm gonna go with 0.25. Okay, I'm gonna leave it to 0.2 actually, not 0.25, like so. Yeah. And another thing, nice thing about Fusion is that you can simulate this. You can see how it's going to behave in a real scenario. So when you, yeah, I'll do it again. So you right click and you go to simulate here, and you can select stock visibility over here, and you can hit play, and you'll see how it's actually going to cut the thing. And this is really nice to visually check how things are gonna go. So whether your settings are all right, whether nothing really unpredictable happens. because even though these are machines and computers, like very precise computer numerical tools, they are made by humans, and algorithms are made by humans, and not all parts are necessarily perfect. So it might be that there are some glitches, and then yeah. Here you can see, so these are the tabs actually, so that are going to hold this material down, and we are going to use the chisel to remove these parts from the material, and that's that. So basically, we have the tool paths, and now we are ready to save them to file. We have to close the simulation panel first. Yeah. So for saving them to file, we need to use this post-process menu item. And yeah, we have this panel open now. And for the settings, we need generic posts, which are included with Fusion 360. We are using Mac 3 controller software for the Exitech CNC machine. Program number, not important at this point. Units should be millimeters, and we can hit OK. And I'm going to save it somewhere in the desktop. DFS box demo. And so usually with a file name, I try to include the some essential parameters that are included in this design. So I would say that box parts, 4mm tool, 16.7mm material. That's somehow important. And yeah, and then the next thing that I want to do is to save this onto a flash drive. I'm going to disconnect the right device from my computer, which is going to be the mouse. I'm going to copy the whole folder, this. And here I have also the good. So yeah, I copied it on the USB disk here, but I just ejected it as well. Okay, so with this, now we conclude so we finished the toolpath part. So let's take a 5 to 10 minute break and continue with the machine. And meanwhile, I'm gonna set up the microphone with the. So it's gonna happen on the other camera. So since we are streaming with 2 cameras, so thus I'm going to connect this microphone to the other computer in the CNC room. For those who are watching, hopefully, and yeah, let's switch.